All right, y'all, let's do this. Hey, y'all, it's Ventura here. Welcome to today's lesson. Today's lesson is going over Dalton's law, which is also known as partial pressure. All right, so let's get into it. Okay, so Dalton, we actually talked about him earlier this school year when we were learning about the history of the atom. Dalton had four postulates. Okay, the postulate that we covered in class was about atoms. Okay, he stated that all matter is made up of atoms which are indivisible or can simply not be divided. Dalton also had a couple of ideas as well, with one being the concept of partial pressure. So, reading on the PowerPoint, his law says this, okay? It states that the total pressure exerted by a mixture of gases is equal to the sum of the partial pressure of each individual gas. So, what does that mean? Let's take the air in your room right now. It's going to be a mixture of different gases: carbon dioxide, water, because Houston's very humid, oxygen, because we need to breathe that in order to live, as well as two other random gases like nitrogen and argon. Each of these gases are going to be in different amounts, and they will each exert a different amount of pressure. Okay? Real quick, guys, let's recap what pressure is. Pressure is the amount of force or the number of collisions of gas particles, okay? So the more collisions you have, the greater pressure you're going to feel, or the greater pressure that gas can exert. And so all these gases can add up to create the air in your room, and all these pressures will add up to a grand total like the formula down here, okay? P total refers to the sum of all the gases in the room. P1 plus P2 plus P3, and so on and so forth. So we add the pressure of oxygen, nitrogen, argon, water, CO2, and then we get the total pressure in your room. Okay? Now, what we're going to focus on today is working on finding the partial pressure of each individual gas in a given scenario by using something known as the mole fraction. But that's going to be on the next slide. Real quick, for this slide, guys, I do want to practice real quick just finding the total pressure of all the gases when you add them up. And so, guys, example number one reads like this. A 2.0 liter container is pressurized with 0.25 atoms of oxygen gas and 0.6 atmospheres of nitrogen gas. The question is asking what is the total pressure inside the container. And so, guys, we are going to find the grand total. And so what we're going to do is simply this. Your formula in the last slide states that the total pressure in the system is the sum of all the gases. So we have two gases in this problem. We have oxygen, which we'll call PO, plus nitrogen gas, which we'll refer to as PN. And so the question is asking for the total pressure. What are we simply going to do? We're going to add up each of the pressure. So our total is going to be the sum of, okay, oxygen has a pressure of 0.25 atmospheres, while nitrogen has a pressure of 0.6 atmospheres. And so what we're going to do is 0.25 plus, what is it? 0.60. We add up these two numbers. So therefore, your grand total is going to be 0.85, and your units are going to be in atmospheres, and so it'll be 0.85 atm for atmospheres. Okay, pretty easy. Out of each gas, you can get a grand total, and vice versa. Okay, I can give you the total pressure of a container and give you one of the gases. You simply subtract the total from one of the partial pressures. Now, guys, this is where it gets more complicated now. So, earlier on in the last slide, I said that. Ooh, let me go backwards. Go back. Awkward. However, it is what it is. So going forward now, Give me a second, guys. This is being weird right now. Aha. So, going backwards. Okay, so we can find the partial pressure of a gas by multiplying the total pressure by the mole fraction. And so, guys, let's revisit one of our favorite topics, which is going to be the mole. In this case, mole fraction. Now, why is the mole always coming back? Remember when we first learned about the mole, we learned about Avogadro's constants, okay? Avogadro postulated or theorized that at a given any gas at a certain volume, certain temperature, certain pressure is going to have the same number of particles. So we have two different gases. Let's just say oxygen and hydrogen, okay? At the same temperature, same pressure, etc., there will be equal number of gas molecules. Now, the mole fraction is a proportion of one particular gas within a large mixture of gases, okay? It's the ratio, so to speak, okay? It's like saying, hey, the human body is made of X percentage of water. To find the mole fraction, all we do is take the moles of the element that we are working with, divided by the grand total of all the moles in that system or in that container. To find the partial pressure with the mole fraction, all we're doing is partial pressure will be equal to your total pressure in your container or your system multiplied by the fraction of that particular element. And so, guys, let's go into our first example. So in this scenario, we have a 3.0 liter container that has 4 moles of helium, 2 moles of neon, and 1 mole of argon. These are all normal gases. Right? The question is asking what's the mole fraction of neon gas and what's the partial pressure of neon if the total pressure of this container is 5 atmospheres. So for this problem, guys, we're going to have two parts, okay? So part one is going to be dealing with the mole fraction itself, okay? Let's practice real quick how to find the mole fraction. I promise, guys, it's easier than it is, or it's quite simple. So mole fraction, okay? Your formula is this. The mole fraction, okay? Let's just call it, let's call it X of I is going to be equal to the mole of your element. So I'll just put mole of elements. Let's extend this over here. Divide by your total moles. Ooh. Total mole, okay? And so we're trying to deal with the partial pressure or the mole fraction of neon gas. But if we're going to do that, then we need to find our total moles. We'll do that up here. So total moles, all right, guys, is going to be equal to all these moles added together. So we have 4, 2, and 1. So we do 4 plus 2 plus 1 will give us a grand total of 7 moles. Okay? So we're going to do the mole fraction of what? Of neon. And so all we do is simply do neon is how many? It's 2. So we do 2 over 7. That's it. That's your mole fraction, is 2 over 7. So we've got the mole fraction. Now, over here now, we're going to do the partial pressure, guys. So now we have our partial pressure. Ooh, spelled it incorrectly. All right, so now we have partial pressure of the neon gas. And this is when we use the new formula, okay? So the new formula states that your partial pressure, which we'll call P of P, is equal to your mole fraction multiplied by your total pressure. You know what? Let's just call this P of T for total pressure, okay? So in our problem, we know our total pressure is going to be 5 atmospheres. And so we found our mole fraction, which is 2 or 7. And so guess what, guys? What we're going to do is simply do the partial pressure of neon, which is P of Ne, is going to simply equal 2 over 7 multiplied by 5. And guys, what do we get? 2 times 5 gives you 10 over 7. And so guys, that's your answer. Simply add your units, which is atmospheres. So we have ATM, and this will be your answer. Ta-da! Easy peasy lemon squeezy. Unfortunately with me, guys, it's never that easy. And so let's move on to our last example, which is going to be a fun one. Okay? So for this problem, let's read it. A mixture of gas has 2 moles of hydrogen, 3 moles of ammonia, 4 moles of CO2, and 5 moles of nitrogen gas. The mixture has a total pressure of 800 torr. Real quick, guys, okay? Real quick. A little quick recap. Pressure can come in different units, okay? It can be in atmospheres. It can be in kilopascals, okay? It can also be in millimeters of mercury, and it can also be in a unit known as torr, okay? So just keep that in mind, guys. There are different units of pressure. So torr is still unit of pressure, okay? So the total pressure is 800 torr. The question is, what is the partial pressure of each of these gases? So guys, what that means is we're gonna find not just the partial pressure of hydrogen gas, which is H2. We're also going to do ammonia, which is NH3. We're also going to do good old carbon dioxide, or CO2. And lastly, we're going to have nitrogen, which is N2. So we're going to do 4 partial pressure calculation, okay? Practice makes perfect, right, guys? So step 1, let's go into it. Hydrogen gas. The first part is going to be the mole fraction. So mole fraction. Ooh, that didn't come out right. So mole fraction, guys. Now, the mole fraction, all right, we'll just call it X of I. All right. Actually, no, scratch that. X of He, or X of H. H2. So we're trying to find the mole fraction of hydrogen gas. We know its value is going to be 2. So we're going to have 2 on top of this fraction. Real quick, let's find our total mole. I'm going to write total mole. Okay, will equal. So we simply have 2 plus 3 plus 4 plus 5. We equal, all right, 4 plus 5 gives you 9. 9 plus 3 gives you 12. 12 plus 2 gives you 14. Yay, all right? So 14 is your total number of moles. So we simply have 2 over 14 as our fraction. And guess what, guys, real quick? 2 over 14 can be reduced to 1 over 7. So remember mole fraction. The next step is to find the partial pressure. Ooh, that came out wrong. Partial pressure. And so what we're going to do is to find the partial pressure of hydrogen gas, all right, which is what? H2. We simply do 1 over 7 multiplied by what? All right, our total pressure, which is 800 torr, okay? So 1/7 multiplied by 800 torr. And once you do that, guys, you're going to get your partial pressure of hydrogen. So you do 1/7 multiplied by 800, and your answer is simply going to be, all right, 114 points. Let's round up to 0.3, and that's going to be the answer for hydrogen. 114.3 torr. We're going to do this for the next 3 gases. And so over here for ammonia, we're going to find its mole fraction, okay? So X of, something small, NH3 will equal. Ammonia has a value of 3/14. We can't reduce that, so we're going to go on to find the partial pressure. The partial pressure of ammonia is going to equal simply 3/14 multiplied by 800 torr. And so you punch in your calculator, you do 3/14 multiplied by 800, and you get as your answer 171.4 torr as your answer. Okay? Find the fraction, multiplied by your total, and then you get your partial pressure for that gas. The next one is going to be CO2. So to find the mole fraction of CO2, we take our what? Our moles, which is 4. Ugly 4. Let me fix it real quick. So over 14. We keep going. The partial pressure of CO2 is going to equal, we do 4/14 multiplied by 800. And so you simply type in your calculator 4/14 times 800, and you're simply going to get 228.6 torr. Now, we're at the last gas, which is nitrogen. Now, Dalton's law states that all these gases, hydrogen, ammonia, CO2, and nitrogen, add up to 800. For this last one, we actually don't need to do all these steps. We can simply do this. We can do our grand total, which is 800, and we subtract each of the partial pressures. So we subtract 114.3. We also subtract 171.4. And we also subtract 228.6. And so you do all of this math, and then, so 800 minus 114.3 minus 171.4 minus 228.6. And, my calculator made an error. What the heck? I see. Points. And there we go. My calculator made an error. Your answer is simply going to be, all right, so the partial pressure of nitrogen gas is going to be 285.7 torr. That's it, guys. That's all it is. When you get to your last gas, you don't have to do the steps. You simply subtract all of the other parts so you find your last piece, okay? And guys, that's really all I have for today, all right? Thanks for watching my video. Have a good day. Feel free to message me any questions. Later.